Okay, so here's a really good example that'll break this down and hopefully make it a little more understandable. They don't show you everything in the book if you're reading that, so if you're still confused after reading the book, this might help a little bit. Okay, so an object travels at a steady rate along a straight path. So it's starting at the point -5, 3, and it's traveling to 3, -1. That's fine. You could graph that. That's not, but I'm not going to do that right now. Okay. In the same plane, oh, the object is in the same plane, in 4 seconds. So that's the time element right there. The t is from 0 to 4. It's taking from 0 to 4 seconds for that object to travel that path. Okay, the coordinates are measured in meters. Find parametric equations for the position of the object. So what you're going to do first is you're going to think about x, okay? X is starting out, think about x and t, okay? So at 0 seconds, it's got an x value of -5, okay? So the object is starting at -5 for the x value, and that's at 0 seconds. And then it's going for 4 seconds, and it winds up at an x value of 3, okay? So you're comparing the time, when did it start, when did it end, to position, the position being the x position, okay? That distance. Okay. So those are 2 ordered pairs. You can find the slope of those. So, remember the slope formula. So I'll just, I hate to put m because we're going to use that for meters, but the slope would be 3 minus -5 over 4 minus 0, because we're trying to find the parametric equation for x of t. That's what we're trying to do. Okay, and then that gives you 8 over 4, which is 2, and that's meters per second. Okay, so that's the rate, I guess, the object is going, 2 meters per second. Okay, now that you know the slope, and you also know the y-intercept, you can write the equation. So you can say x of t is equal to 2t minus 5. Okay, that is the one parametric equation. Okay, you can graph that parametric equation. It's starting at -5, 1, 2, 3, 4, 5, has a slope of 2, good old linear equation. And that's what's happening over time based on the x value, okay? All right, now we're going to do the same thing for y. So we're going to say, what happens to the y value based on time? So we know when there's 0 time, the object's starting, it's got a y value of 3. And it's going for 4 seconds, and then it winds up at -1. Now these are nice because they're linear, and that's nice. So slope, again, -1 minus 3 over 4 minus 0, which gives us what? -1 meter per second. Okay, so you could think about, I guess, the object in a plane dropping, 1 meter per second. That would be a rate. Okay, so now we write the parametric equation. It's linear, so y of 2 is going to be this slope, -1t, and then you also know the y-intercept, so plus 3. That would be the other parametric equation. So comparing, I didn't label my axes. This should be x and this should be t, because that parametric equation is matching to that graph. You're basing it on t time and the x position, okay? So now this is going to be y and t. And let's see, we're at 3, 1, 2, 3. And then we've got a -1 slope. So that's how the y position is changing. So that graph matches to that. What happens when we put it all together? Okay, so then we can make like a little table of ordered pairs. We could say, what's t? And then what's x of t? And then what's y of t? And we'll go ahead and do this. Now we're going to go ahead and start at 0 seconds. That makes sense. We don't have any negative time here. Okay, so when you plug in 0, you get an x of -5. You get a y of 3. And so the ordered pair, x of t, comma, y of t. Yeah, I should put x of t probably here. Y of t. Now it's all messy. Okay, so -5, comma, 3. And we knew that that's the position where it was starting. Okay, they told us that in the directions. Now, 1. So after 1 second, now what is x of t? Well, it should be x of 1, I guess. So x of 1 is equal to 2 minus 5, which is -3. And then what is y of 1? -1 plus 3, which is 2. So you get this ordered pair -3, 2. Now I'm going to go ahead and graph those two ordered pairs. So -5, 3, 3, positive 3, right there. And then -3, 2, right there. And now what happens at 2 seconds? So x of 2 is going to be, it winds up being -1. And then y of 2 is going to be 1. So you get -1, 1. And then, let me scroll up. Whoops. So then at 3 seconds, x of 3 is going to be 1, and y of 3 is going to be 0. So you get the point 1, 0. And then at 4 seconds, so when the object stops, then you have x of 4, which is going to be 3, and y of 4, which is going to be -1. So you get the point 3, -1, which in fact, if you go back up, that's where it ends, right? So 3, oh, you know what? I think I drew the last point wrong. Get that one out of there. 1, 0. Yeah, I did that wrong. Okay, so 3, -1. There it is. And it should be linear. It doesn't look very linear. Why is that? Oh, because I still drew it wrong. Okay. This is a long video, too. Okay. So it was 1, 0, which is right there, and then 3, -1. There. Now it looks better. Okay. So what does all this mean? So think about a bird. The bird starts here, and it's going to fly over here. And then this is where it is after 1 second. This is where it is after 2 seconds. This is where it is after 3 seconds. And this is where it is after 4 seconds. Okay? So that's the position that the bird would be in. Okay. Hopefully that helps.